we talk about dynamic array. You can use new and delete to allocate memory space. However, this approach is not recommended. We do not recommend you manually allocate memory because this will cause some memory safety issues. Here is one news about software memory safety. And many companies like Microsoft and Google, they find about 70% of their bugs comes from memory safety issues. So memory safety issues are very common. And because C++ offers flexibility for memory management, and this will rely on programmers to manage memory. And because C++ do not have some protection mechanism about memory allocation, so for C++, it is if you manually allocate memory by yourself, this can lead to some problems. So we recommend do not manage memory by ourselves. And you can choose some libraries. For example, you can choose to use vectors. The purpose of vectors is similar to dynamic array. It can grow or shrink, but you don't need to allocate memory by yourself if you use vectors. So next we will learn how to use vectors. And you can next I will introduce the standard C++ library. For STL, if you want to use containers, container means it's like an array. A container contains many elements, and we have a lot of options. If you learn data structure, you will learn stack or list or queue. So if you need to use such data structure, you can use the standard template library. And in our course, I will introduce the vector container, and the usage for other containers are similar. So each container has its own purpose. You can choose the proper container for your task. So vector is similar to dynamic arrays. Vector can grow or shrink. You can add elements or delete elements from a vector, and it is defined in the standard template library. And here, template is a special syntax in C++. It is the template usually use angle brackets. So if you see angle brackets, this refers to the template class. So here is here introduce how to initialize vectors. I will show some examples. So to initialize an array, we use braces. You can initialize an array using braces. And to initialize a vector, we can use similar syntax. You can also use a pair of braces to initialize a vector. So here I declare a vector. So here is we use the data type vector angle bracket double. So this is like an array, a double array. So each inside the bracket is the data type. So here we declare a vector of scores, and each element is an array, is a double. And we use a pair of braces to initialize this vector. And you can see that the difference is that we don't need to determine the size of this array. You don't need to determine the size of vector. Its size is automatically determined by its initial value. So its initial value contains 5 elements. So if you call the size member function, this member function will return the number of elements in this vector. So here, after declaration, I use a for loop to print each element in this vector, and you can see the syntax is almost the same for an array. So you see, you can use a vector like an array, and it is even easier because you can directly obtain the vector size by the size function. The third method is the second method is you can use pushback. Pushback can automatically increase the size. So first, you can use method 2 and then use pushback. Pushback can only add one element, and later we will see this method for my vector for method 2. And the method 3 is to copy from one array. So method 3 use some is existing array as the initial value of a vector. So for example, so here I will use array as the initial value of scores. So here after the vector we follow by a pair of braces. This is known as constructors. Later we will learn this is known as constructors. We will use constructor to initialize a vector. So here we use constructor. And for this constructor, we specify the range we want to copy. So suppose we want to copy the entire array. So the beginning address is the memory address of the first element, which is array at the index 0. And then the second input is the end point of the memory address. And because we want to copy seven elements, so here we use +7, which means we want to copy 7 elements. And actually, this is pointer addition. If you perform pointer addition, this will generate another pointer. So after these, scores will be 1, 2, 3, up to 7. Actually, you can choose the range you want to copy. For example, if I only want to copy begin from 3, then you can modify the initial. You can modify the initial pointer. So the initial pointer, if you modify to array +2, this means you want to begin from the element at the index 2. So after this modification, scores will become 3, 4, 5, 6, 7. And you can also modify the endpoint. You can suppose I only want to copy the 2 elements at index 2 and the index 3. Then you can specify the begin and the end pointer like this. And you can see the vector size is automatically determined by the number of elements you copied. So you don't need to worry about memory allocation, because vector will automatically perform memory allocation for the desired operations. And if you want to copy, if you want to initialize a vector from another vector, you can use similar syntax. So now suppose you want to initialize scores from another vector named revenues, and you can then you can also use syntax like pointers. Here I copy the entire vector, and you can also specify the range you want to copy. However, you cannot use expressions like this because revenue is not an array, so its name does not represent a memory address. So you cannot use expressions like this. This causes syntax error. So here you need to use begin and end to obtain iterator pointing to elements in a vector. So here we will call begin to obtain the memory address of the first element of a vector. Suppose I only want to copy the first 3 elements. So here I can specify the range I want to copy. And you will see the score size is automatically set to 3. And suppose you want to copy the entire vector. And you can also specify the range you want to copy. For example, if you want to only copy the middle 3 elements, then you can modify the begin and the end operators, iterators. So you see the scores will be initialized to 3, 4, 5. And the method file is to initialize all elements to the same value. For example, you want to initialize all elements to 1, and the vector size is set to 5. Or you can use syntax like this. This is also a constructor. So you can so you see here, if I declare scores like this, so this expression will create a vector with 5 elements, and each element is set to 10. So you can, so this is very convenient if you want to generate 100 elements, and each element is set to 10. So you see the initialization of vector is very flexible. It's very flexible than the built-in static array. For static array, you can only use method 1 for static array. So static array, you cannot use method 3, method 5. So use static array is very restrictive. Here is a comparison between vector, static array, and vector. If you want to initialize an array, we can use a pair of braces. And for vector, you can choose to use constructor like this. But the right hand side is more flexible, because if you want to initialize 100 elements, then it is not possible to use the static array, because if you use static array, you need to manually write down 100 once, or you need to use a for loop to initialize 100 elements. So to initialize 100 elements, using vector is easier. And if you want to initialize all elements to once, for static array you can use syntax. You can use a pair braces to initialize all elements to once. However, you cannot write statements like this. So if you only specify one element, the remaining elements will be set to zeros. So this will not initialize all elements to once. So if you want to initialize all elements to once, you need to use the array method 1. You cannot use array method 2, because method 2 only initialize the first element to 1, and the remaining elements will be set to 0. This is according to C++ rules. However, if you use vector, this will be very easy. So you can call the constructor to set the 5 elements to be 1. So using vectors is easier than the built-in static array. And for vector assignment, the usage is similar. Assignment means you use the equality. You can use the assign operator to perform assignment from some vector or some array. So you can assign one vector to another vector, or you can assign one array to another vector. And this is very flexible, because for built-in static array you cannot do this. You cannot assign one static array to another. But for vectors you can do this. So actually you can perform here you can assign. You can use assignment to initialize this vector. So you can even assign array, static array. Also, only you can only assign vectors, but for static array you cannot use assignment. You need to use constructors. So you see, if you try to assign static array to vectors, this causes data type mismatch. So the correct usage is like this. You need to call the constructors. So here we can assign one vector to another vector. This is very intuitive, but for static array, you cannot perform array assignment. So below are some member functions you can use to access elements in a vector. We can use brackets, or you can use the at function. This is similar to the brackets, but at function is better because at function can determine whether I is inside the legal range. So next, I will use some example to illustrate the difference between at function and the brackets. Actually, we recommend to use the at function because at function can detect index out of range. And if you want to access the first element, you can call the front member function. And if you want to access the last element, you can call the back function. So here you see that I print the first element and the last element. So first element is at the index 0, and the last element is at its size -1. So you see the outputs are the same. So it is easier to use back member function if you want to obtain the last element. And you can use the at function to replace the brackets. So their purpose is the same. But add function is better because if you try, because add function can detect index out of range. I will show some examples. So here I try to sorry. So here I try to access the element at the index size, and you see this expression. This expression is not legal because I try to access elements outside the vector. So this statement, so you see, if I compile the code, the syntax is correct because I can generate the machine code. I can also run the machine code. The program can output the value. The value at this index is a very small number. However, the expression like this is very dangerous because the index is outside legal range. So actually, we want to detect such error. So actually, if you write expression like this, this can cause runtime error. But if you use brackets, brackets cannot detect index out of range. However, if you replace brackets with add function, then you can see when you run the code, it will generate a runtime error. So at this line will throw an exception out of range because the index is 7, which is equal to the vector size. And this means the index is outside the legal range. So this line will cause runtime error. So if you use the add function can help you to detect index out of range. So we always recommend the use of add function. Because if you use brackets cannot let you detect index out of range. So about how to access vector elements, we already show we can use for loop to access vector elements, or you can use iterator to access array elements. This is like use pointers to access array elements, or you can use range-based syntax. It's usually like this. You don't need to create index. So in method 1, we need to use index I to access each element. For method 2, you don't need to use index I. Each element is denoted by this variable. So you can use any ELEM is any variable name. You can change it to other variable name. So I always recommend to use method 1 because this is more intuitive. It is similar to the built-in static array. So method 1 is more intuitive. The next, this slide shows a problem in where I saw in some students' assignments. So, can you find any problem with the following code? This is from some students' assignments. Can you see where the problem is? If you try to run the code, we can try to run the code to see what will happen. See here, we see that the program has runtime error because the XC code is not 0. But actually, you don't know what happened to this code. You just know some runtime error occurs. However, you can change the bracket to add function. So if you use the add function, you will see more message. So this line will throw an exception of index out of range. It says that the vector size is 0. So for this expression, the vector size is 0. The index I is 0, and the 0 is greater than or equal to the vector size. So this means the vector size is 0. And since the vector size is 0, if you want to access, if I is 0, then this calls index out of range. So the problem comes from you do not initialize vector 2. So actually the size of vector 2 is 0. So you see here, we do not initialize vector 2. And therefore, the size of vector 2 is 0. So you cannot use expression like this, because 0 is calls index out of range. The size of vector 2 is 0. You cannot. It contains no elements, so you cannot access any elements inside this empty vector. So the correct way is you can initialize. You can to correct this program. You need to properly initialize this vector 2. So you can use syntax like this. Maybe you have a variety of ways. For example, you can assign VEC1 to VEC2, or you can use constructors. You can specify the vector size. And actually, you have one more choice if you prefer to not if you prefer not to initialize vector 2. You have another choice. Another choice is to use pushback. So if you choose not to initialize vector 2, this is fine. But you need to use pushback to add elements to vector 2. So here I choose not to initialize vector 2. So its size is always still 0. However, here I use pushback. Pushback means to add one element to this vector, and pushback will automatically perform memory allocation. So pushback will increase the size of vector 2 by 1. So here I perform so here you see we push each element of vector 1 to vector 2. So actually vector 2 will be the same as vector 1. And the following for loop prints the value inside the vector 2. You can also perform some mathematical operation. For example, I perform +1. And you can print the vector 2 the size of vector 2 for each pushback. So here I print vector 2 size, the size of vector 2 after pushback. You will see after first pushback, the vector 2 size is increased to 1. After the second pushback, the vector 2 size is increased to 2. So the vector 2 size is increased by 1 for each pushback function call. So this is very different from static array, because for static array you cannot adjust array size. But for vector, if you want to increase vector size, then you can use pushback. But you cannot use bracket or use add function to adjust vector size, because we already see brackets will not adjust vector size. So from this example, you see the vector size can be adjusted, and actually it is automatically allocated. So you don't need to worry about memory allocation, because the vector library handles memory allocation internally, so you don't need to worry about memory allocation. So to use a vector, you need to understand if you do not initialize a vector, then its size is empty. Then you need to pay attention when its size is empty. So if the initial size is empty and you want to add, if you want to add vector elements, you need to use the pushback function. You cannot directly use assignment, because assignment will not aid. If you use assignment, this will not aid vector elements. We have more functions to add or delete elements from a vector. We already see pushback, and to delete elements from the last element, you can use to delete the last element, you can use popback, and you can also clear the vector. And if you want to insert one or multiple elements, you can use insert. And if you want to delete one or multiple elements, you can use erase. So these functions can automatically perform memory allocation. So it is very convenient to use vector if you want to add or delete elements from a vector. So this is much better from new and delete by yourself. I think the time is up, so we can take a break for 10 minutes. Let's continue our class. I will show some examples about how to use, how to delete and how to add and delete elements from a vector. And suppose you can declare a vector like this. So this vector initially will have 5 elements. And if you perform pushback, so you push back 1, then 1 will be added at the end of this vector. So this vector becomes so 1 is added after the first pushback function call. And if you push back the second element, if you push back 2, then 2 will be added at the end of this vector. And then if you perform pop back, and this means you want to delete the last element, the last element in this vector. So 2 is deleted from this vector. And now suppose you want to erase the first 2 elements. So suppose you want to erase the first 2 elements from this vector, then you can call the erase member function, and you need to specify the range you want to erase. And here the first input is an iterator, and this iterator points to the first element. And because we want to delete two elements, so here the second input is begin plus 2. This is similar to pointer addition. So after this function call, the first two elements are deleted. So the remaining elements only contain four elements. And you can also use insert to add elements to this vector. And you need to supply the location you want to insert this element. So here we specify we want to insert at the beginning of this vector. So you see 10 is added at the beginning of this vector. And you can also insert multiple elements. So in the next function call, we insert 3 negative ones at the beginning of this vector. So after this function call, 3 negative ones are added at the beginning of this vector. And you can practice the usage of these functions. So here I define a function to print the elements inside this vector. Then you can try to practice. For example, we can call the pop function. So after the pop function, the last element will be deleted. So pop, it's pop back. Also, it's pop back. So you see the last element is deleted after the pop back function call. And you can try to insert element using insert. So suppose I want to add 3 at the beginning of this vector. So here first I specify the location I want to insert. So after this function call, 3 will be added at the beginning of this vector. So here I need to supply the iterator to specify the location. So you see, 3 is added at the beginning of this vector. So I will write down the results after each function call. Then you can also add multiple elements. So now suppose you want to add 2 negative ones at the end of the so suppose I want to add 2 negative ones. So suppose I want to add 2 negative ones after the first 2 elements. Then you can make a function call like this. So you see, after this function call, the vector is as expected. And you can also try to erase. You can also try to erase elements. For example, suppose I want to erase the last 2 elements. Suppose you want to erase the last 2 elements. You can call erase. So now suppose I want to remove the last 2 elements. Then you can make a function call to erase. And you need to specify the range you want to erase. So the range is vc2.end -2 and vc2.end. So this will remove the last 2 elements. Next, I will introduce the size and the capacity for a vector. We already know what size is. Size refers to the number of elements in this vector. And the capacity means the memory allocated for this vector. So actually, the capacity is always larger than size. So capacity means the number of bytes you allocated to this vector. And the capacity is always greater than size. So for this example, the size of vector is 5. And the capacity is 8. And the begin member function will return an iterator points to the first element. And the end will return an iterator pointing to the element next to the last element in this vector. So actually end does not pointing to the last element. it's actually outside this vector. So for our example, you can try to print the size and the capacity. So after each function call, I print vector size and vector capacity. You can see how the two size changes. So you see after the first function call, the size and capacity are all set to 5. And after pop back, the size is reduced by 1. However, the capacity remains the same. And after insert, the capacity also remains the same. Here we can try to insert more elements. So example, if you insert 10 elements, so you see here after this function call, we add the 10 elements, and the size and capacity are adjusted to 14. So you see, actually vector will automatically allocate memory space for you according to your function call. So here is some experiments about size and capacity. Suppose we declare a vector and we do not perform any initialization. So the size and the capacity should be 0 after this declaration. And then I create a nested for loop. Inside the outer for loop, I will create another inner for loop. And in each inner for loop, I call pushback to add one element to this vector. So after one inner for loop, 500 elements will be added to vector. And then I print array size and array capacity to see what will happen if I call pushback 500 times. Then I repeat this process from I equals 0 to I equals 5. So I repeat this experiments 5 times. So initially we see that we do not initialize vector, so its initial size and capacity are all zeros. And for I equals 0, the inner for loop will call push back 500 times. So after the inner for loop, we see the size is increased to 500, and capacity is increased to 512. And the capacity is always greater than size. So you know that capacity is always larger than size. And why the number is 512? This depends on the implementation of the vector library. So actually, we don't know the capacity because this is this depends on the library implementation. But what we know is capacity is always larger than greater than or equal to size. Then for the second iteration, for I equals 1, again we call pushback 500 times. Then the size is increased to 1000. And this time we need to adjust the capacity because 512 is less than 1000. So the capacity is adjusted to 1024. It doubles from the previous capacity. So for the after the second inner for loop, the vector size is increased to 1000, and the capacity is doubled to 1024. And for the third inner for loop, for I equals 2, we add another 500 elements. So the size increased to 1500. And again, because 1024 is less than 1500, so we need to increase the capacity. The capacity is doubled to 2048. And then we do the same process. We add another 500 elements. The size is increased to 2000. And this time we don't need to adjust the capacity because the capacity is sufficient to contain 20 elements. So the capacity remains the same. And after the final, when I equals 4, we add another 500 elements. The size is increased to 2500. And this time we need to adjust the capacity because the capacity is smaller than 2500. And again, the capacity doubled. So you see the capacity is always larger than size. And actually, we don't want to frequently adjust the capacity because if you frequently adjust the capacity, this will be time consuming. This means you allocate the memory very frequently. So usually we do not frequently perform memory allocation. Next, I will introduce another function related to memory allocation. So we have two member functions, resize and reserve. Resize means you allocate memory. You want to allocate memory. But reserve does not create elements. So if you co-resize, this will not change. This will not change the size. The size. So reserve will not change the size. If you want to change the size, if you want to change both size and the capacity, you need to use resize. So resize allocates memory and also creates instances, create elements. So here you can try to use resize and reserve to compare resize and the reserve. So after the function call, after I call reserve 100, after this function call, the size remains the same. The size is 0. However, the capacity is set to 100 elements. Actually, it's 100 integers. So the capacity after the reserve function call is set to 100. If you change reserve from resize, and the result will be different. And you see, for resize, the size is also adjusted to 100, and the capacity is also 100. So the resize member function adjusts both size and the capacity, while the reserve member function only adjusts the capacity. And you can see this is very convenient to use vector. Because if you want to resize a dynamic array by yourself, you need to return the memory. You need to return the memory, and you need to allocate it the memory space you want. And you also need to create elements. So you see, resize. Actually, this function call performs a lot of operations. And if you want to implement these operations, you need to be very careful about memory allocation. But if you use vector, you don't need to worry about such tasks, because vector will automatically perform memory allocation for you. So we always recommend you use vectors if you want to use dynamic array. And we have finished this chapter. So we have finished the vectors. And then we will go to the next chapters, strings. And let's see the slides. For strings are very common data types for programming. First, I will recall C strings. C strings is actually static array used in the C programming language. So first, the first part I will introduce C strings. The second part I will introduce C++ string. String is a data type introduced in the C++ programming language. And C++ string is more convenient than C string. Later we will see. And the third part is about string input-output. I will introduce some functions to deal with string input-output. So C strings is actually a static array, and with one additional requirement. The static array must be end with the null character. And the C++ string is a data type. It's actually a template. And we always recommend C++ string to C strings, because C++ string is like a vector. You don't need to worry about memory allocation. But for C strings, you need to allocate memory by yourself. So to use C string, you need to pay attention to memory allocation, which is requires a lot of efforts. So let's see what is a C string. A C string is actually a string, an array of characters. So you see, this is an array, and each element is a character. And a character is enclosed by single quotes. So we use single quotes for each element. And the one additional requirement is that at the end of this array, we must be the null character. The null character is \0. So below is a character string, but not a C string, because it is not end with the the null character. So you see, this is not a C string, because it is not end with the null character. Actually, we have a convenient way to initialize a C string. So you can use a pair of braces, or you can use double quotes. And the two are equivalent. So the first one is equivalent to the second one. And you will see the first one is more convenient, because if you use double quote, you don't need to add the null character, and you don't need to type many single quotes. So we usually use the first statement to initialize a C string. Here is one example. So I declare a C string. So I use a double quote to initialize this C string. And do you know its size? What is its size? the size operator will return the number of bytes for this variable. So you need to determine the number of bytes with this variable. So if you count, we have 5 characters. So this variable has at least 5 bytes, and the result should be 6. So you see, the result returns 6 because we need to include the null character. So here we have 5 characters, and 5 plus 1 plus the null character. So this size of returns 6. Means this array has 6 bytes. So actually, str1 is equivalent to str2. It's actually equivalent to an array of 6 characters, and the last character is the null character. So you see both str1 and str2 has 6 bytes. And here we perform initialization by this assignment operator, and we do not specify the array size. So the compiler will automatically determine the array size by the right hand side. So for this example, we do not specify array size, and the compiler will determine the array size from the right hand side. However, sometimes you can determine the size by yourself. The size must be greater than 6 because the right hand side has 6 characters. So the size must be greater than 6. So if you use 5, this leads to syntax error. So the size is at least 6 for this example. And actually you can use larger size. You can use 10. So actually you can use larger size. And if you use larger size, then the size of this string becomes 10, becomes the number you specified. Now you have a problem because you only specify 6 characters, but the left hand side you specify 10 elements. So we have 4 elements not specified. And do you know what is the value of the remaining 4 elements? And you can recall the rule. The rule for you can recall the rule to initialize an array. So if we can see the rule for array initialization. So you remember that if the array size is different from what you specified, then the unspecified elements will be set to 0 automatically. So this is the C++ rule. So if the array size and the right hand side does not match, then the unspecified elements will be set to 0. And this rule also applies to strings. So for strings, we use the same rules. So the remaining 4 elements will be set to 0. Actually, you can verify this by yourself. We can print the value of each character. So here I try to print each character, but some characters are invisible because the null character is invisible, so you cannot see the this element. So I will enclose each element by a parenthesis so that you can see the position of each element. So you see that I add a parenthesis around each element. So each element is quoted by a parenthesis. And you note the null character is actually empty. So inside the parenthesis is empty, because you cannot print the null character. And you will see, so you see nothing. You can, because inside the parenthesis is empty. However, if you want to know the value, you can perform typecasting. You can perform typecasting to integer. Because each character can be treated as an integer. So if you want to print the integer value of this character, you can perform typecasting. So I change the data type from character to integer, so you can see the integer value. And you will see the integer value of H is 104, and the integer value of E is 101. And the integer value of the null character is 0. And the remaining 4 elements are also set to 0. So actually integer 0 is the null character. So you see for this C string, the first 6 elements is set to is set by this pair of braces. And the remaining 4 elements are set to 0 by the C++ rule. And the 0 is actually the same as the null character. And you can search the ASCII value. You can search the ASCII code or ASCII table. and you can know the integer value of each character. So you see that each character, for example, later h is here. Its integer is decimal. Its decimal value is 104. So its value is 104. And the decimal value of e is, so e is here, is 101. And actually you don't need to memorize, you don't need to memorize the integer, the ASCII value. Later I will show you why. So you don't need to memorize this ASCII value. And you can find the null character. The null character is here. Its integer value is 0. And also, you need to distinguish lowercase and uppercase because they correspond to different integer values. And actually, each character has corresponding ASCII code. For example, the space. For example, the space corresponds to 32. And the null character is invisible, so you cannot see the null character. And the tab character corresponds to integer value 9. So here is if you declare a C string, and if you specify the array size, so here we only specify 3 characters, and the remaining 2 elements are not specified. And according to the C++ rule, the unspecified elements will be set to 0, and the 0 is equivalent to the null character. So the remaining characters will be set to the null character. So here you can try to print the ASCII value by typecasting to integer. And actually, you can use a character like an integer. So you can perform subtraction. For example, you can perform character B minus character A, which is 1. Because if you look this table, character A is 97, and character B is 98. And if you perform subtraction, you perform B minus A, this is equivalent to 98 minus 97. So you can perform subtractions for characters. And actually, you don't need to. So here you can try to perform subtractions. So here I perform subtract character A. And the result will be the difference between, for example, character H and character A. The difference will be 7, because corresponds to 104 and the A corresponds to 97. So 104 minus 97 is 7. So you can perform. You can treat character like an integer. And the A is 97. So if you perform 0, you perform 0 minus 97, you got negative 97. I think the time is up, so the class can be dismissed.